All right, this one is there was typo in here that I posted this on my website. We are missing one given. The segment ED is parallel to segment BC. So if you couldn't do this proof because of that, I'm so sorry. But if that's the reason you couldn't do it, just don't watch the video now. Try to solve it yourself, and then check the answers later. Okay, if you want even close, then just watch it and see if you can do it on your own later. So you should print out a new one. I posted a new one on the website, and that one has this given in it. Okay, so let's go over the roadmap first. So this is a parallelogram, right? A, B, F, G is a parallelogram. So these are parallel, and these are parallel, right? And then D is a midpoint of AC. So these are congruent. Okay. And we want to make DF is 1/2. No, DF, I'm sorry, where is DF? DF is congruent to AE. So we want to make these congruent, right? So if you look at this triangle, this is a midpoint, and these are parallel by the given. The ED is parallel to this, and then that means these are parallel too, because these are parallel. But this goes through a midpoint, and these are parallel, so this has to be a midpoint, right? And if this is a midpoint, then these are the same length, right? And now look at this triangle, ABC. D is a midpoint, and these are parallel because A, B, F, G are parallelogram. These are parallel. So it's going to the midpoint, and it's a parallel to the base. So this has to be 1/2 of this length. And since these are congruent, 1/2 of this is this, and then therefore they have to be equal. So that's the roadmap, okay? So let's start by saying that E is a midpoint. So let's see. We want to make these a parallel, and that's a midpoint. Oops. Okay, so A, B, F, G is a parallelogram, and that's given. And no, actually, that's not what we are using. Sorry. We are doing this one first. ED is parallel to BC. You can start with parallelogram and make this 1/2 first. That's fine with me as well. And so two, these are parallel, and this is a midpoint. So this is a midpoint. Okay, so we want to say that D is the midpoint of AC, and that's given. So 3, E is the midpoint of AB. And the reason for this is if a segment goes through a midpoint, the midpoint of a side of a triangle and is parallel to the second line, then it goes through midpoint, the midpoint of the third line. Okay, so if E is a midpoint of AB, then AE is 1/2 of AB, and that's the midpoint theorem. Okay, now we want to make this df 1/2 of AB, and then we are done. So first we want to say that this is these are parallel, and this is a midpoint, and these are parallel. So then this have to be a midpoint, and since two sections going through, this have to be 1/2. Okay, so we already said this, and so we want to make these parallel. So you have to say that it's a parallelogram. ABFG is a parallelogram, and that's given. So AB is parallel to GF, and this is a definition of parallelogram. But you can say that if the opposite sides of parallelogram are parallel, right? If you're not sure if it's a definition or characteristics, just write it out, then you'll be fine. Or you can say if ABFG is a parallelogram, then AB is parallel to GF. You can write that as well. That always works. Okay. All right. 7. These are midpoint, so we want to say that F is a midpoint. BC, and it's the same as this one. Okay, so if a segment goes through the midpoint of a side of a triangle and is parallel to, you can say, another line, another side, then it goes through midpoint of the third line or last line or the other line. One of those would do. All right, so now this is a midpoint and this is a midpoint, so this have to be half the length. You can actually go straight to that. So DF is 1/2 of AB if segments connect midpoints of two sides of a triangle, then it is 1/2 the length of the third side. So since these are the same, you can say that DF is AE by substitution property of step 4 and 8. Oh, sorry, you couldn't see. All right. So DF equal AE and substitution property of 4 and 8.